Hello everyone, welcome to my YouTube channel. I am Sabina Aydınova. Today I'm gonna show you finding this limit of function by using L'Hospital-Bernoulli's rule. We're using calculating the limits of functions by Bernoulli and L'Hopital's rule. When we get indeterminacy, uncertainty, like 0 over 0, infinity over infinity, in these cases we use this rule. What is this rule? We just differentiate the both numerator and denominator of the function to get the result. But in this task, this is a little bit different from the others because we don't have something fraction, and we have to get to it as a fraction. How will we be doing it? But this is indeterminacy too, because the when limit of the function when x tends to 0 to the power sine 0 is equal to limit when x tends to 0 to the power of 0, because sine 0 is 0. This is 0 to the power of 0 is also indeterminacy. But why is L'Hopital's rule? We have to convert it something bit fractional. This part of function f of x or y is equal to x to the power of sine x, and I'm gonna write this x as e to the power of ln x, because e to the power of ln x is equal to x, so I can write it like this: e to the power of ln x sine x. This is x to the power of sine x. We didn't change anything, we just substitute x as e to the power of ln x to get the result. But now, from now on, I'm gonna just look at the power of it: sine x times ln x. Sine x is equal to 1 over cosecant x. 1 over cosecant x times ln x. We didn't change anything here, we just substitute sine x as 1 over cosine x because they're identical, they're equal to each other. And now limit when x tends to 0. This part, I'm gonna only look at the power of it, not ln x over cosecant x is equal to, now I'm gonna differentiate both numerator and denominator of the function. Derivative of ln x will be 1 over x, and derivative of cosecant x is equal to cosecant x times cotangent x is equal to, this x will be in the denominator, then 1 over x times cosecant x is equal to 1 over sine x times cotangent x is equal to cosine x over sine x. Then that's equal to sine square of sine x will be in the numerator over x times cosine x, and that I'm gonna part this multiplication as sine x over x times cosecant x over sine x over cosine x. They are same, I just I divided into two parts, that the multiplication of it is still the same. Then limit of this then x tends to 0, sine x over x times sine x over cosine x will equal to, I can write it as limit of function sine x over x when x tends to 0 times limit of function x tends to 0 sine x over cosine x is equal to, you know that this is equal to 1. This formula, you have to know it. And this part with b, this is limit of x tends to 0 tangent x, or we can write a sine 0 is equal to 0, cosine 0 is equal to 1, and 0 over 1 will be 0, limit of function constant 0 when x tends to 0 will be 0. So 1 times 0 is 0. Then we get the limit of the function of the power limit x tends to 0 ln x sine x or ln x over cosecant x is equal to 0 after calculating it. Then let's look at the total function. Limit x tends to 0 e to the power of ln x times sine x is equal to limit of function x tends to 0 e to the power of, we found that limit of this function is equal, when x tends to 0 is equal to 0, and limit x tends to 0 e to the power of 0 is 1. Then limit when x tends to 0 1 is constant, then it is equal to 1. Solution of this task is in this way. I hope that you enjoyed and learned how to find it. If you like this video, please hit the like button, and please subscribe to my YouTube channel, like my videos, and leave a comment to support me. Thank you for watching this video until the end. Yeah, you can check out my other mathematical videos. Goodbye.